All right, we've had a little look at angular velocity acceleration and just angular displacement. So I told you that the whole thing just transfers from linear, and it does. So if we remember our formulas for kinematics, which we should, because in year 12 we should have memorized those. Remember, there were two D formulas and two V formulas. And the D formula, we'll just write one here. D equals Vi plus Vf all over 2 times t. And we've got that other D formula, V initial times t plus at squared over 2. So if we want to change those into angular formulas, then we just substitute everything. We just D becomes theta, Vi becomes omega I plus omega f all over 2 times t. Works. Same with this one, theta equals Vi omega I times t plus alpha t squared over 2. And we can do the same thing with our other formulas, which were f Vf squared equals Vi squared plus 2ad, so that's omega f squared equals omega I squared plus 2 alpha theta. Can you remember the last formula? Vf equals Vi plus at, which is the same as omega f equals omega I plus alpha t. So we've got those four formulas, and you could be asked questions with those little guys. You could get a turntable, for example, rotating, and the question might be, okay, this little baby on the edge starts from rest, and the acceleration is so much, and they might ask you, after so much time, what's the displacement? And you just plug them in the usual way. Couple of things to think about. When you've got a point rotating on a disk, okay, as usual, that's the linear velocity, right? This here, it does have a centripetal acceleration, and the centripetal acceleration we call A, the little c next to it, and that acceleration is this way. If it was speeding up, it has another type of acceleration, which is a tangential acceleration, and the tangential acceleration in this case is in the same direction as the velocity. So if it was slowing down, for example, then it would need an at in that direction. So you need a force in the direction of the velocity to get a linear acceleration. So these are all formulas, are the linear formulas. We had the centripetal one and the tangential one. Omega is defined as a vector, and the vector they use is the rotation point or the pivot point. So you actually end up with omega being a vector into the page or into the board, and alpha is just delta omega over delta t. So again, the alpha acceleration would be in that direction, but we don't really do the vectors in high school.